This is a short presentation about the Research and Development Division of the Puerto Rico Seismic Network. Research studies at the Puerto Rico Seismic Network are carried out by 3 professors from the Geology Department. These are Elizabeth Vanacore, Victor Huerfano, and Alberto Lopez Venegas. The Puerto Rico Seismic Network Research and Development Division seeks to understand the seismic and tectonic environment of the Puerto Rico Virgin Island region by engaging into high-quality research studies using state-of-the-art geophysical instrumentation. These researchers at the Puerto Rico Seismic Network carry out a great variety of research projects by engaging both graduate and undergraduate students that attend University of Puerto Rico, Mayagüez. The Research and Development Division at the Puerto Rico Seismic Network is subdivided into 4 main categories: seismology, tectonics, tsunami, and sea level. Let's start by looking at seismology. Seismological studies at the Puerto Rico Seismic Network is carried out by using a total of 26 seismic stations that are distributed throughout the island of Puerto Rico, the eastern part of the Dominican Republic, and the Virgin Islands. The stations provide the necessary data to conduct research that help understand our tectonic and seismic environment. We know that real-time data allows seismic activity monitoring and provide instantaneous earthquake locations. However, archived data is used to carry out specific research studies to define the internal structure in our region and the Caribbean, provide information about location and orientation of active inland geological faults, and studies related to ground motion. So 2 main divisions are being studied for seismological studies. Structural seismology. In this particular area of interest, the seismology research at the Puerto Rico Seismic Network include a variety of projects stemming from the real-time monitoring in the region. These projects range from large-scale structural seismology studies to engineering seismology. Structural scale studies include investigations focusing on the structure of the PRVI microplate using traditional methods such as tomography, as we can see here in these pictures to the right, that use both local and teleseismic earthquakes, and you also use statistical analysis of local earthquakes, swarms, and earthquake relocations of significant seismic sequences, just like the current Southwest Puerto Rico seismic sequence that started back in December 2019. Some other studies in seismic structure is the ground motion studies at the Puerto Rico Seismic Network. These studies are done in collaboration with our sister network, the Puerto Rico Strong Motion Program from the Civil Engineering Department, and also uses the collaboration of the United States Geological Survey staff. This includes recent studies into the local amplification in Mayagüez from the Rumshake experiment, as well as current work on the development of new ground motion prediction equations to be employed in future seismic hazard maps in the region. Our second division is looking at the tectonics of the region. For this, we employed Global Navigation Satellite Systems, GNSS, which have been proven to be a very useful tool to quantify the motion of tectonic blocks on the surface of the Earth. These research studies involve post-processing of GNSS data, which shows that the Puerto Rico Virgin Islands block is a separate, independent block moving away from the Caribbean. Moreover, the recent seismicity of the southwestern region of Puerto Rico is the result of separate block motion in the southwest, as it has been shown by studies of GPS and GNSS data. Real-time data, on the other hand, provide instantaneous site motions that are critical and very helpful in determining seismic parameters in real time. The third division of research at the Puerto Rico Seismic Network is tsunami modeling. The Puerto Rico Seismic Network relies on several supercomputing nodes, which are used to carry out very computing-intensive tsunami simulations of both earthquake and submarine landslide sources. Simulations have allowed the development of tsunami inundation evacuation maps for the entire island of Puerto Rico and some islands of the Lesser Antilles. So we can see here on the left panel, bottom figure, is an example of an evacuation map for the municipality of Aguada. This map is showing the locations of inundation-prone areas for a set of tsunami sources from earthquake sources. This municipality is located in the northwestern part of Puerto Rico. In the central part, there is a snapshot of a tsunami simulation of the 1918 submarine landslide as a probable cause for the tsunami that was observed then. So we can see how the effects of these possible sources occurred in the past, but we're interested also in looking at how these events could affect us in the future. And for that, we can modify the actual bathymetry from potential sources on the northern coast of Puerto Rico. And this is shown the Loíza Amphitheater, just 20 to 30 kilometers north of the northern coast of Puerto Rico. And we can see in this figure a nested grid of different resolution grids that allowed us to look at the effects of tsunami simulations in the coast. As it can be shown in this figure, different snapshots for the greater San Juan metropolitan area after 5 minutes, 10 minutes, 15 minutes, and 25 minutes after the onset of the hypothetical submarine landslide. The fourth and last division of research at the Seismic Network belongs to sea level studies. The Puerto Rico Seismic Network operates and maintains a total of 10 state-of-the-art sea level monitoring stations. We also receive data streams from 9 other stations throughout the island, which belong to the National Oceanographic Atmospheric Administration, plus nearly 40 other stations from around the Caribbean region. We know that catastrophic tsunamis have occurred in the past, and having ways to quantify wave heights is critical to confirm the occurrence of a tsunami in the region. It is important to know all this because on any given day, the Caribbean region could harbor close to 500,000 people on their coast, therefore boasting the capability to detect and alert in the fastest way possible, which could save thousands of lives. So where do we go into the future? World seismic and tectonic, sea level, and tsunami modeling research will continue into the future, because this research at the PRSN stems beyond traditional seismology by acting as a multidisciplinary subduction zone observatory. Researchers will continue to investigate the region to understand better the tectonics as well as the seismic and tsunami hazard of the region. Thank you for your time. This has been a short presentation about the Research and Development Division at the Puerto Rico Seismic Network.